is home to the largest nuclear missile program in the world. It's more than likely that they plan on using them against us. We plan on stopping them. Tomorrow at 0800, we attack the...
Sir, there's a slight problem with that.
What is it this time, Lieutenant Smarty Pants Guy?
Well, we don't really know where the base is, sir.
Well, this is embarrassing. Can you just do some of your smarty pants stuff and figure it out?
Well, now that you mention it, I can. It's a simple case of hyperbolas.
Wait, you already have it done?
Yes, we've been provided with a polar equation. R is equal to 18 over 2 plus 4 cosine theta. From the cosine, we know that this graph is running in the x direction. So we take the 4 over 2 equals 2. Therefore, it is a hyperbola, which we already know. So we have theta and r, and we need to plug in 0 and 270 degrees. Because this is cosine, it runs in the x value, we'll be using the unit circle graph 0, 270 degrees. When we plug in 0 degrees, we get out 3 for r. And when we plug in 270, we get out -9. Looking to the graph, we see 0, 3, so we go 1, 2, 3 over. For 270 degrees, we receive a -9. So we will be going to the right 9 rather than to the left. So we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are the vertices. To find the center point, we count the total distance between the two. This total distance here is 6. So we divide 6 by 2, which is 3. Start at one vertex, 1, 2, 3. This is our center point. Now that we have the graph, I can find out all the fine detail. To find the center point, we have already calculated. It is 6, 0. To find the vertex, we take our center point, 6 plus or minus 3. The 3 comes from the 1, 2, 3, 1, 2, 3 in each direction. And it is with the 6 because the 6 is the x value in which the graph runs in. Then we have the 0. We have the focal point, which we know is always going to be at 0 in polar equations. So we count 1, 2, 3, 4, 5, 6. 6 plus or minus 6, 0. In turn, we can find this focal point, the enemy's base, as 1, 2, 3, 4, 5, 6. Here is the German base. To find the eccentricity, which is pointless, we will take f, 6, the plus or minus value, over v, 3, the plus or minus value, and we get 2. As up here, we can confirm that this is right. Now that we found all this stuff, we can calculate the rectangular equation. We first look at our center point, 6, 0. The 6 is in the x, so x minus 6 squared. We get the minus because it's positive, we write the opposite. Below this value is 9. We find this from looking at the vertices. 3. We square 3 to get the 9. Then we subtract, because this is a hyperbola, it is running in the x value, so the y value will be negative. The y value does not move, so it remains y squared over, and to find this bottom number, we look down here. 9 plus x equals 36. I got the 9 from the 3 after squaring it, and I received the 36 after squaring the focal point. And then x equals 27. That goes below the y value, and we have found our rectangular equation. Now we search for our asymptotes. Y is equal to. To find this value before the x, we look at the rise over run. Y is the rise, x is the run. So we take 27 over 9x. And to get minus 18, we plug in the center point. 6 times 27 over 9 is equal to 18, so we need to subtract 18 in order to get the 0. In the opposite case, once we times 6 by negative 27 ninths, we get negative 18 and need to add 18 to get 0. Now we have the asymptotes, we won't travel into any unknown German lands or nuclear waste.
So now that we actually know where the base is, we'll...
Sir, the Mounties. They're attacking.
What? Why?
Canada, they've allied with the Japanese instruments. They have rocket launchers on their freaking saddles.
Dear God.
Well, now with Canada in the equation,
You have to do that now?
the Canadian's base is located by the parametric equation x equals 6 tangent theta, y equals 4 secant theta plus 5. The y is positive because it has a secant, and the graph will run in the y direction. We convert this to a rectangular equation for better understanding. The positive y value has the negative 5 with it. Though the 5 is positive in the parametric equation, it switches to a negative because it's always opposite in the rectangular. We square this as always, and below this number here, we look at the y. There's a 4 with a y, so we square it, getting a 16. For the negative value, we have x squared, for there's no number after the theta. Under the x value, we see we have a 6, so we square the 6 to get 36. And of course, it's equal to 1. From this, we can derive the center point as 0, 5. There is nothing with the x, so it's 0. And there is a negative 5, which is really a positive 5. To find the vertices, we have 0, 5, our center point. Plus or minus, look to the positive value in which the graph is running, 16, take the square root, and we get 4. Now, to find the focal point, if you look over here, we have 16 plus x equals 36. We get these numbers from the equation. The hyperbola equation is minus, so we will be adding these values. So 36 minus 16 to solve for x, and we get 20. Now these are squared values as seen in the original equation. We take the square root of 20, which is simplified to 2 square roots of 5, and we put this after the plus or minus with the focal point. Now we have the bases, but we also need the eccentricity because for no reason. We start with the focal point value after the plus or minus, 2 square roots of 5. The vertice value after the plus or minus is 4, so we take 2 square roots of 5 over 4 and get the square root of 5 over 2. As you can see, it has been simplified. Now we can graph our hyperbola and find out where the Canadian base is located. So plotting this, we start with center point of 0, up 5. Right here is the center point. Then we look down for the vertice, 5 plus or minus 4. We start at the 5, go up 4. Here is our first vertice. We go down 4, our second vertice. Now we look at the focal point. We have 0, 5 plus or minus 2 square roots of 5. 2 square roots of 5 can be simplified to 4 point something. So we go up 1, 2, 3, 4. Right here, this red dash is the focal point and also the Canadian's location. Our base, on the other hand, is down 4 point whatever. So we go down 1, 2, 3, 4. Right here is our base where this red dash is. Now we need to find the asymptote so we don't invade any foreign lands, just to be on the politically correct side. So we take the y, which is rise over run. So this is why we start with the y value. 16 over the run, 36. Down here, you can see I took the square root of 16 and over the square root of 36 to get 4 over 6, which is equal to 2 over 3. Y is equal to 2/3 x as we calculated here. And then y is equal to negative 2/3 x. Now we plug in the center point, 0. 0 is plugged into x to get 0. And in order to get 5, we need to add 5. The same applies to the negative equation. We need to add 5 in order to get there from 0.
Signor Mountain, America hito wa Roger that. Bring in the raid.